All right, welcome back to AP Physics C. Just clearing some stuff off the screen there, sorry. So AP Physics C, Unit 1 for electricity, magnetism, electrostatics. This is the last video where we're going to focus on the electric potential of different charge distributions. Okay, what you see on the screen actually is very important because, again, there's our charge densities, right? So the infinitesimal size charges that we break up our configurations into based on 1 dimension, 2 dimension, and 3 dimensions. Okay, so first thing, again, we're going to treat a continuous charge distribution as a collection of infinitesimally separated individual points, and that's what leads to our charge densities, our lambda, sigma, and rho. Now, when we treat them as such, we will end up with an integral, right? Because remember, we have a relationship between electric potential and the E field. Okay, so V equals E dot dx. But you remember E is KQ over R squared. And so another way that you can kind of do this is what we did in the electric potential or the electric field video is we just started with what does V equal, right, which is KQ over R. And then we could just kind of like work our way, what are we varying? Well, we're going to vary the amount of charge per unit length or per unit area, per unit volume. And then we can do our integral, right? And so we're going to say dV is going to be equal to the integral, or so dV is going to be equal to K dQ over R. And then when we finally take the integral, right, we're going to end up with V. And I'm going to take the integral here. It's going to be the integral of K dQ over R. And then you just figure out your dq based on your configuration. Okay, so let's look at an example problem. So again, we're going to go back to our ring of charge. Typically, the question will be like part A, find the E field at this point. Part B, find the electric potential at this point. So we have a ring of uniform charge density of lambda, units of Coulomb per unit meter of arc. Really, this is a ring. Okay, find the electric potential, not point. Potential at a point on the axis passing through the center of the ring. So again, just like in our other video, R is going to be root x squared plus a squared. Okay, and we just start, right, just like we did towards the end of the notes portion, KQ over R. Well, we're doing a dV, so it's going to be dQ over R. Right, and this is going to be because we're going to charge changes per unit length. That's why we use like a linear charge density, volume charge density, area charge density. And we know, so we go back to our kind of notation that it's going to be so it's going to be Q is going to be 2 pi R lambda, right? Because this is going to be our L, our total length. That may come into play. It may not come into play. And so how to go from the dV K equal to K dQ over R? Well, we take the integral. And so V is going to be the integral of K. Oh, sorry, put a D there. So K dQ over R, but K and R are constants. So I can bring them out of my integral. And so it's going to be K over R integral dQ. Well, that's just going to, again, this is going to be our charge density, right? And so that's just going to be KQ over root x squared plus a squared, which is one potential answer, right? And then the other potential answer would be if I now plug in this 2 pi R lambda to get in terms of lambda. So it's going to be K, and we'll plug in what K stands for. Remember, 1 over 4 pi epsilon naught. Right? And we're going to multiply that by 2 pi R sorry, it's going to be 2 pi A, because it's the radius of our ring, times lambda over root x squared plus a squared. And we can do some canceling again, just like we did in the previous video. So 2 becomes, the 2 over 4 becomes 1/2. Pi would cancel, right? And so we end up with lambda a over epsilon naught root x squared plus a squared. Okay. So your two answers are what's boxed there in red and then what's boxed here in green, right? Depending on what, you got to pay attention to what they're actually looking for. Okay. They may look for it in terms of Q, in terms of, maybe in terms of a lambda. So this ends unit 1 for AP Physics C, right? So that's the electrostatics unit. In the next unit, we're going to talk about conductors, capacitors, and dielectrics, because there's some special things that we need to address before we move into unit 3, which is electric circuit.